So let us talk about UML. We'll see why this model, UML, and principles of modeling, because this is a modeling language. And what is UML exactly? Conceptual model of the UML and building blocks in this, rules of UML and common mechanisms. So why this model? We analyze the problem domain, simplify the reality, capture the requirements, visualize the system in its entirety, and specify the structure and behavior of the system, and design the solution. How to design the solution? We document the solution in terms of its structure, behavior, and other factors. So what is the principles behind the modeling or of modeling? Choose your model well. That means the choice of model profoundly impacts the analysis of the problem and the design of the solution. And every model may be expressed at different levels of precision. Because the same model can be scaled up or down to different granularities. And the best models are connected to reality. We simplify the model but don't hide important details. And no single model suffices, so every non-trivial system has different dimensions with the problem and its solution. So what is UML exactly? UML is Unified Modeling Language. U for unified, M for modeling, and L for our language. So UML is a modeling language, not a methodology or process. Please understand it carefully. That is a modeling language. So it fuses the concepts of the BOOCH, OMT, Object-Oriented Software Engineering methods. And it was developed by Grady Booch, James Ivar at Rational Software. And it is accepted as a standard by the Object Management Group, OMG, in 1997. So UML is a modeling language for visualizing, specifying, constructing, and documenting the artifacts of the software system. Again, it is a modeling language to visualize, specify, construct, and document the artifacts of the software systems. So visualizing means a picture is worth 1,000 words. So graphical notation articulates and unambiguously communicates the overall view of the system. That is the problem domain. And specifying means UML provides the means to model precisely, unambiguously, and completely the system in question. And constructing means models built with UML have a design dimension to it. So these are language independent and can be implemented in any programming language. So it's not just with your object-oriented concept this UML is connected. It is generic. It can be applied to all sorts of programming paradigms. Then documenting. Every software project involves a lot of documentation from the inception phase to the deliverables. So document is for requirement, design, and tests. So UML provides notation for documenting some of these artifacts. Conceptual model of UML, the building blocks, means things, relationship, and diagrams. And rules are there, and some common mechanism, that is the specifications, adornments, common divisions, and extensibility mechanisms. So UML building blocks has things such as structural, behavioral, grouping, annotational. Relationships has dependency, association, generalization, and realization. And diagrams are class diagram, object diagram, use case diagram, behavior diagram, implementation diagram. So there are so many. Now structural things, the nouns of UML models, usually the static. These are the static part of the system in question. It's a class, an abstraction of a set of things in the problem domain that have similar properties or functionalities. The notation is like this: customer. It's a noun. Now comes the interface, that is a collection of operations that specify the service which is rendered by a class or a component. This is like this. Okay. Then we have collaboration. Collection of UML building blocks like classes, interface, and relationship that work together to provide some functionality within the system. This is like notation is account system. This is the notation of collaboration. So here we see we have class, we have interface, and now the collaboration. Now use case, an abstraction of a set of functions that the system performs. A use case is realized by collaboration. Notation is like this. This is an abstraction of or a set of things that system performs, right? Now active class. A class whose instance is an active object. An active object is an object that owns a process or thread, that is units of execution. And then we have event manager like active class. So notation for the component, which is a physical part, this typically manifests itself as a piece of software of the system. The notation is like this. Then we have node, a physical element that exists at runtime and represent a computational resource, typically a hardware resource. The notation is like this. Print server, this is a hardware sometimes. And the verbs of UML models usually they're dynamic. These are the verbs. So we have seen the nouns, now the verbs. These are the parts of the system in question. Interaction, so behavior constituted by messages exchanged among the objects. The exchange of messages is with a view of achieving some purpose. Notation is like this. Parse. Then we have state machine, a behavior that specifies the sequence of these states an object goes through during its lifetime. So state is a condition or situation during the lifetime of an object during which it exhibits certain characteristics or performs some function. Like this, ending idling. Now the grouping of things, the organization part of the UML model, it provides a high level of abstraction like granularity that has package. A general purpose element that comprises UML elements like structural, behavior, and event grouping things. So packages are conceptual grouping of the system and they need not necessarily be implemented as cohesive software modules. The notation is like this. These are the packages for accounts, department, etc. Then we have annotational things, the explanatory part of the UML models. This adds information meaning to the model elements like note, a graphical notation for attaching constraints or comments to elements of the model. And the notation is like this. This is a annotation like parse, user query, and build, expression stack. Then comes the relationships. It articulates the meaning of the links which is between things, like dependency, a semantic relationship where a change in one thing causes a change in the semantics of the other thing, that is a dependent thing. So this is independent, this is dependent. So notation is like this. Arrowhead points to the independent thing. An association, a structural relationship that describes the connection between two things, like this. And the generalization, a relationship between a general thing called a parent and or a superclass, and more specific kind of things like a child and a subclass, such that the latter can substitute the former. The notation is like this. Arrowhead points to the superclass. Now, realization, a semantic relationship between two things, wherein one specifies the behavior to be carried out and the other carries out the behavior. That is, the collaboration realizes a use case. That is, the use case specifies the behavior, that is the functionality which is to be carried out, and the collaboration actually implements that behavior. Notation is like this. The arrowhead points to the thing being realized. So the graphical representation or presentation of the model, these are the diagrams. It is represented as a connected graph, like vertices connected by arcs, with things related by relationships. So UML includes 9 diagrams, each capturing a different dimension of software system architecture, like class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, component diagram, deployment diagram. So we have class, object, use case, sequence, collaboration, state chart, activity, component, and deployment diagrams. 9 in all. So class diagram, the most common diagram found in object-oriented analysis and design. It shows a set of classes, interfaces, collaborations, and their relationships. This models the static view of the system. Object diagram is a snapshot of a class diagram. models the instances of the thing contained in a class diagram. The use case diagram. It shows a set of use cases, which is a set of functionality performed by the system. The actors, which is typically people or systems that interact with this system, and the relationships, means models what the system is expected to do. Then sequence diagram, that is models the flow of control by time ordering, depicts the interaction between various objects by of message pass and with a temporal dimension to it, sequence diagram. Then collaboration diagram, models the interaction between objects without the temporal dimensions, merely depicts the message which is passed between the objects. State chart diagram. It shows the different state machines and the event that lead to each of the state machines. So state chart diagram shows the flow of control from one state to another. Activity diagram. It shows the flow from activity to activity. An activity is an ongoing non-atomic execution within a state machine. Then component diagram. It shows the physical packaging of software in terms of components and the dependency between them. Then comes the deployment diagram. It shows the configuration of the processing node at runtime and the components that live on them. So, dimensions of this software architecture: user view, structural view, behavioral view, implementation view, and environmental view. So, user view, use case diagrams. Structural view, you have class diagrams and object diagrams. And behavioral view has sequence, collaboration, state chart, and activity diagrams. Implementation view, you have component diagrams. And in this environmental view, you have deployment diagrams. The rules specify what a well-formed model should look like. UML has semantics rules for names, scope, visibility, integrity, execution. Common mechanisms, elements that apply consistently throughout the language, like specifications, adornments, common divisions, extensibility mechanisms. These are the nodes. An extensibility mechanism has stereotypes, tagged values, and constraints. Adornments adorn the model, that is, enhance the model, adds to the meaning and semantics of the element to which it pertains. The nodes are the mechanism which is provided by UML for adorning a model, that is, enhancing the model, adding information to the model, extra information. So, graphical system or symbol to render constraints and comments. And a node that renders only a comment has no semantic impact on the element it is adorning. So at most adds meaning to it and provides guidelines for the implementation. Stereotypes. This is used to create new building blocks from existing block. New building blocks are domain specific. A particular abstraction is marked as stereotype, as this stereotype is then used at other places in the model to denote the associated abstraction. Notation is like this: meta class. These are stereotypes. Then comes the tag values. It is used to add to the information of the element, and not to the instance but to the element. So the stereotypes help create new building blocks, tag values help create new attributes, and commonly used to specify information relevant to code generation and configuration management. The notation is like this: version is equal to 1.4, these are the tag values. Now constraints. This is used to create rules for the model. The rules that impact the semantics of the model and specify conditions that must be met. So it can apply to any element in the model, attributes of a class, relationship, etc. And the notation is incomplete, disjoint. So, to summarize all this, modeling captures the system in its entirety along with the different dimension of its complexity and facilitates quick and efficient analysis and design, and helps communicate the overall system architecture unambiguously. So the principles of modeling lay down that model must be chosen well, models should encapsulate different granularities, models can make simplifying the assumptions but not hide important facts. A single model can capture all dimensions of the complexity, and UML is a language that helps analyze and design solutions for software-intensive systems. So developed by Bush, Tanenbaum, and Jacobson at Rational Software, subsequently adopted as an open standard by the Object Management Group (OMG) in 1997. So UML is a modeling language to visualize, specify, construct, and document the artifacts of the software system. So it is a modeling language or not a methodology or a process. The conceptual model of UML comprises the building blocks of UML, the rules and the certain common mechanisms that are applicable across the entire language. And the building blocks comprise the things, relationships, and diagrams. So things are grouped into 4 categories: structured things, behavioral things, group things, and annotational things. And the structured things describe the static part of the model and are of 7 types: class, interface, collaboration, use case, active class, component, and node. And by the behavioral things, this describes the dynamic part of the model and are of type interaction and state machine. And the packages are included under grouping things like nodes, under annotational things, and relationship link things to each other and are of 4 types: dependency, association, generalization, and realization. So diagrams are essentially connected graphs, a set of vertices connected by arcs, relationship. So there are several types of diagrams, each one capturing a different dimension of the system complexity. And diagrams are of 9 types: class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, implementation diagram, deployment diagram. So the UML has semantic names, rules for name of specifier, classifier. So scope of these names, visibility of these names, and integrity and execution of the model, all UML has. So certain component, these common mechanisms apply uniformly across the model. There are 4 such mechanisms: specification, common divisions, adornments, and extensibility mechanism. So nodes are the most common adornments used that add to the meaning of a classifier. And extensibility mechanism includes stereotypes, tag values, and constraints. Thank you so much. Hope you got a bit idea of UML now. Take care.